simply because of the need to store things and analyze. And then Dan's going to finish off talking about cloud monitoring and cloud logging. We also do have our partners up on stage with us today, Fastly, Equinix, and who's the last one? Tableau. So they will be up on stage as well. We have some live demos, we have some videos, we have lots of information. So without further ado, I will hand over to Jerzy, who's going to come up and talk about compute. Welcome, Jerzy.
Oh. All right. So can we get the other slide deck, please? All right, so my name is Jerzy. I'm a product manager on Google Compute. And I'm going to talk about the Google Cloud Platform and specifically compute. So when you think about Google, you probably think about this. Very clean page, a logo, a text box, a couple of buttons. When I think about Google, I think of this. I think of the infrastructure. I think of the data center, the networks, the servers. It looks great, isn't it? But it hasn't always been like that. So back in the day, our web page was very clean. But we had a very, very huge infrastructure problem ahead of us. First, our app, the search, was having infinite appetite for the computing power. Second, the servers were too expensive. We also had very little money. And the data centers, as you know them today, were pretty much unknown back then. So in the meantime, our growth chart looked like that. So we've been growing 10 times in 5 months, right? And by the way, when you see a traffic chart this jagged, this means you have a serious availability problem, right? And honestly, back then we did. So we needed to change the things fundamentally, right? So first we started from a cheap custom servers. And well, recall back in '99, Linux wasn't all that great. And for example, our front end was crashing every few hours, literally, because of the bugs in the Ethernet and in the networking stack. And we clearly were in the early stages of getting the hardware right. So a few years later, things look a little bit better, as you can see here. But really, the first couple of years were a constant struggle to survive next week's traffic increase. So when we finally got some time to breathe, we started to rethink the infrastructure from scratch. So search really changed everything because it had infinite capacity needs. It required massive parallel computation. It required to reinvent hardware, software, and the services. And it required us to come up with a whole lot of innovations in the computer science, like GFS, Bigtable, MapReduce, Kubernetes, etc. So we've taken all of these investments into data centers and in the cutting-edge computer science, and what we offer is compute on the Google Cloud Platform, which is these three things that I'm going to talk about today: App Engine, Compute Engine, and the Container Engine. So let's start with one. App Engine is your platform as a service. If you want to focus on the code, not on the infrastructure, this is where you should go. You just work on your application, and we take care of everything else. So let's start with an example. This is my web page. Well, it's actually a bottom of my web page that is having a 1990s style of a guest book, where you can leave a comment on how much you like my page and how you enjoyed my animated GIFs. So, well, as an application, pretty simple, but what would you have to do today in order to have a service like that running? Well, you would have to run pretty significant infrastructure. You would need front-end servers, you would need a back-end server, you would need to provision a database, you would have to stitch it all together. Then at the end, you would have to deploy it 3 times so that you have one version for developer, me, one version for test, me, and then one version for production, where your users would actually be accessing your web page. So once you have it, once you test it through all of these phases, you would deploy it to production. And this is where your problems would really start, right? Because then, well, your page with your GIFs would become super popular. And then, well, you would have to worry on how to scale horizontally, how to handle millions of requests per second. And then also, you would have to start a pager duty so that someone worries about this whole system wouldn't go down. So the promise of the App Engine is you just focus on the first part, and you leave everything else to Google. That becomes your ops. So let's run a demo. Can we get the video, please?
So we've taken a look at all of the infrastructure that I would have to set up to get a simple guest book going. With App Engine, I don't have to worry about setting up any infrastructure, and I don't have to worry about pager duty. Google App Engine is a completely managed platform as a service and allows me to just focus on my code and getting features out the door for my customers quickly. So these are the only 2 pieces of code I need in order to get my guest book up and running. My first piece of code is the app.yaml file, which defines my requirements for the application. So for example, I'm going to write my application in Python. And App Engine works with popular languages such as Python, Java, PHP, and Go. But I'm not restricted to those languages. With a new hosting environment called Managed VMs, I can actually run any language runtime in App Engine. So for example, if I wanted to build this application in Node, I could do that. App Engine automatically auto-scales my application up and down depending on traffic. Or if I want to, I can define how I'd like App Engine to scale. As a developer, I also have popular frameworks built into App Engine. It's really, really easy to add these to my application. So for example, I'm using Web App 2, but I could also use Django, Flask, Spring, and Web2Py. Now, right now, I'm working in a text editor, but I'm not restricted to working in text editors. We have integration of App Engine and popular tools like Eclipse, IntelliJ, and PyCharm. So the app.yaml file defines how I want my application to be run, and now let's switch over to my Python code. And what's really powerful about App Engine is I'm given a number of managed services I can use to build my app. So I don't have to worry about user authentication because I have a service already built for me. I've got Memcache built in, task queues, and a logging service. You know, this is going to save me a ton of time as I'm building my application. And it's really easy actually to export my logs from App Engine into BigQuery for easy analysis. We also have a number of stores for data. So I've got a NoSQL database in this application, but I also have Cloud SQL if I want to use a traditional relational database. So that's my code. It's just these 2 files. I'm going to upload them to App Engine, and my application will run automatically. There's no infrastructure that I'm going to have to provision. So I can come over here to the App Engine launcher, and here you can see my application. So I can run it locally if I want, but I'm just going to go ahead and deploy it. Looks like it was successful. I can switch over to my guestbook right here. So here it is. So with App Engine, I don't have to worry about provisioning or managing any infrastructure. I don't have to worry about scaling my application and load balancing. I don't have to worry about pager duty and worrying about my application going down because Google's handling that all for me. App Engine allows me to focus on features so I can build faster, make my app better, all without worrying about infrastructure.
All right, thank you. So pretty simple, huh? So let's go to a little bit more complex example, the one that I didn't write myself. So any football fans in here? Yeah, right. So you've probably seen this, or at least maybe you have heard of this. That was a campaign run by Coca-Cola back in the day of the World Cup. And the idea of this was to get a social web page that would allow fans, football fans, to submit pictures. And then, well, these pictures would get recomputed into a happiness flag. Let's have a look at the flag first, because this is amazing. Can we get a computer for a second? Okay, it's there. Okay, can you see the pictures yet? Oh, how about now? This was somewhere here. All right. Right, so these pictures were submitted by contributors from over 200 countries. There were over 3.5 million of pictures that ultimately became the happiness flag. So this whole system was built on Google Cloud Platform. Google App Engine was used to build an application that would scale to millions of submissions. Google Storage was used to store all the pictures. Google Compute Engine was used to perform complex computations, resulting in this fantastic rendering. So all of this was done by our partner, CA&T, for Coca-Cola. The system worked great under heavy traffic. Well, these tools were what Coca-Cola and their partner needed to pull off an ambitious project in a very short time. All right, let's go back to the slides. So that was App Engine, right? Popular languages, popular frameworks, popular tools so that you can build faster, right? With the promise that there is less ops or no ops at all, right? And so that it scales for you adequately to your traffic, and you only pay when your page or your app is actually serving any traffic. All right. So let's talk about container engine for a while. I'm sure everybody has already tried it, or has already looked into that, or is very curious why this is such a popular thing and such a hot topic in recent weeks or months, practically. So, as you heard during the keynotes, everything at Google runs on containers, right? We deploy over 2 billion of containers every single week. Why? Because it solves the deployment problem very well, right? So here's some real reasons why you should do that, right? So let's run into a developer scenario. Developer is writing his code, his application on his computer. Everything works great, then he deploys it either to test or to production, and he runs into trouble, right? You heard that before? So then this is a task between him and an ops person to figure it out, right? Because there are dependencies on the fleet of virtual machines that you have to solve in order for the application to work the same way as it works on the computer, right? And the same ops person is also responsible for the best utilization number of the fleet of the VMs, right? Which isn't an easy task. And then all of you IT decision makers, you would like for both of them to not be blocked or not be slowed down with something so simple and so boring as deployment, right? So there is a solution to that. And we're talking about containers. So basically, the concept is super simple, right? Rather than the app code relying on the dependencies on the virtual machine, you bundle them together. You bundle the dependencies in a container. So there are a couple of popular formats, Docker and Rocker, and this is removing all the issues that we just talked about, right? So well, it's easier to deploy across development, test, and production environments. And because of all the dependencies being bundled with the app code and not installed on a VM, well, it's working great. You don't need to fight for resolving all of these issues again and again. And important piece, and containers are a very small unit. There is no operating system overhead, right? So you can package them denser. So you actually get a much better utilization of your infrastructure. So as a result, your developers are as proactive as they can because they do not have to worry about deployment slowing them down. And this is all great. And containers are solving the packaging problem really well. But this is bringing another set of challenges, right? Mainly, well, now that we have all this new great technology and we said, well, it's gonna run everywhere. Well, in fact, where do we run it, right? Where should I run my containers? And, well, not a single container, because this is probably an easy thing. Well, you hire a VM and you run it. But this is not magical just yet. So, well, how do I get my containers to talk to one another, right? Or how do I provision a cluster of them, right? Or how do I ensure they run smoothly, right? And at the end, well, you already decided you want to try out this whole new technology, but how do you make sure that you're not locked in with any particular cloud provider through using this particular technology? Well, Container Engine comes to rescue. Container Engine is very simple. It does 3 things for you, and it does it really, really well, right? First, it sets up a deployment-ready cluster. This is where your virtual machines will run. The second, it makes it easy for me as a developer to declare how I want my containers to run. And then the Container Engine is taking care of the rest. And the third, it offers cloud flexibility, right? It's built for a multi-cloud, word, public, private, or hybrid environments. So with this, let's run another demo. Can we get the video, please?
So let's walk through Container Engine. In this example, I'll be setting up a guest book. I just absolutely love guest books. And what we're going to do is set up a Redis master, 2 Redis workers, and 3 PHP front ends. And all of that code, all of those components, will be wrapped in individual containers. Traditionally, if I were setting up this infrastructure on virtual machines, I would set up a virtual machine for each infrastructure component. So I'd set up a virtual machine for my database server, for my web server, etc. But what we're going to do is work with a container cluster. One cluster that all of my containers will be scheduled into. So creating a container cluster is very easy with Container Engine. I'm simply going to click this button, and we can go ahead and define our cluster. So I'll just go ahead and give it a name. I can select the zone that I want. I can select the machine type for the virtual machine nodes that will comprise my cluster, and I can set the number of virtual machines I'd like to use. So this is really important. What I'm doing is creating one cluster, and it will have multiple nodes as well as a master VM. Then I'll use Container Engine to schedule my containers into the cluster. So all I have to do is click the Create button, but I've already gone ahead and done that. So let's switch over to my code and we can see what we're actually scheduling. So I'm going to move over to my text editor, and here you can see I have my Redis worker controller JSON. This defines how I want Container Engine to schedule my containers. And what I have here is a replication controller. So I'm declaring that I want Container Engine to always have 2 replicas of my Redis worker, and I want each one of those replicas to get 20% of a CPU core. You'll notice that I didn't define what virtual machine I want this scheduled on. I don't have to think about that. I'm just working with the cluster. So I've defined my requirements for each infrastructure component. So you can see I have the front end set up here, and these are my front end requirements. I've got my Redis master requirements, and then I have my Redis worker requirements. So now we can have Container Engine schedule our controllers. I'm going to switch over to the command line, and we're going to run a script. So let's go ahead and list our scripts, and I'm going to simply run cluster schedule. now you can see what it's doing. It's scheduling our Redis master containers, our worker containers, our PHP front-end containers, and finally it's provisioning a load balancer and opening up some ports in our firewall. So all it's doing is telling Container Engine to run the containers based on the JSON files that we just looked at. So here I have the IP address of my load balancer. I'll simply grab that IP address and switch over to my web browser. And here's my guest book. So that's Container Engine. It allows me to very easily set up a container cluster, and then it allows me to easily schedule my containers into that cluster based on the needs that I've declared in the JSON files that we looked at.
All right, so flexibility. The Container Engine is powered by an orchestration system, Kubernetes, that you all heard about a while ago. It is based on years of Google's experience with containers. Most important, it's open source, runs on almost every infrastructure, public or private, and it's supported by a broad ecosystem of partners that is offering great cloud provider flexibility. Right. So that was Container Engine. Now, let's talk about Compute Engine. Compute Engine gets you the maximum flexibility. Right? On the bottom of it all, there are always virtual machines, or machines in general, right? So whenever you have an existing code base, or you have a specific needs that require you go deeper than just the app engine that we talked before, well, you have a whole variety of systems and possibilities with the great pricing. So when you talk about Compute Engine, you think virtual machines, right? And you're right. Virtual machines are at the core of it, right? There are various sizes. They all run various types of Linux or even Windows. And they all run on a Google's network, right? Then, well, Google Compute Engine offers you a services layer across auto-scaling, load balancing, and monitoring. So in fact, here too, you can focus on paying for just what you need without really needing to work hard on disconnecting and reconnecting your machines. This is all happening automatically if you enable auto-scaling. And then, well, Compute Engine handles data-intensive workloads with fantastic industry-leading SSD performance. And it has this great feature, this great unique feature, which is live migration. That would take the image of your running virtual machine and would move it over while serving traffic to another location, whether this is for security patching, whether this is for hardware maintenance, or any other reason. You wouldn't notice it. This is a great feature, especially if you run sustained services or database servers. This is really important. And then, well, last, but also super important, is the pricing flexibility. It's, well, we charge per minute. We have preemptible VMs, and we also have sustained use discount. Let me run a couple examples. The first will be about batch, one will be about sustained use. So you saw the video about atomic fiction. Let's dig into that a little bit in a little bit more detail. So you may have noticed, well, they seem to be a small shop, right? They're a relatively small company. But judging by the infrastructure they're using, they're huge. In fact, because they need to render frames, and these frames sometimes render between a couple of minutes and 40 hours, they're very happy to deploy a farm of computers. And obviously, this is really hard to do on-prem because you either have to wait for very long or you have to spend a lot of money on your own infrastructure. So moving them into the cloud offering was a great step, right? And, well, in fact, they told us they're firing up 750 VMs, right, with over 1,200 cores to render some of their frames. That's a lot of compute power. So when they first moved to the cloud, to our competitors, well, they were happy, but they were also, in a way, unhappy because, well, they were running the rendering for 15 minutes, but they needed to pay for an hour. Or they needed to plan ahead what they're going to do with the remaining 45 minutes. With Google Cloud Platform and the compute, this became much easier, right? And this gave them tremendous savings, which cut across 750 machines makes a lot of money. But also, what they said is, well, it's not like they needed to bend to the cloud anymore. The cloud bent to them, letting them focus on what they do, not worrying about how the way they work and plan is going to impact their bottom line. So there's another option for batch jobs like that. It's preemptible VMs and runs batch jobs for 70% less. This is great for Hadoop, MapReduce, visual effects, rendering, financial analysis, etc. It's limited to 24 hours runtime, and unlike spot instances, the price is fixed and it's making cost predictable. So now that we've gone through 2 examples on batch, let's do something that's not batch and not spiky, right? Let's set up Cassandra, a non-SQL data store that is very performant for a high-read type of use cases, right? So if you want to use EC2, our competitor, well, you provision 2x large machine, 1.6 terabyte, 2 SSDs, 75K IOPS read, 75K IOPS write. This is what you're getting. That's a great server, and you're paying $3,700. Well, on Google Compute Engine, you're provisioning a similar machine, 1.5 terabyte, 4 SSD, Hyman 8, right? Well, first of all, you have a live migration, which is important if you want to run the Cassandra for a long time. But the real difference is in the performance and in the price. It's, in fact, 800% faster read, at 380% faster write, and is 59% cheaper with the 30% sustained use discount. But even without it, it would have been 42% cheaper. So that's a great performance. So that was the introduction to Compute on Cloud Platform, App Engine, Container Engine, and Compute Engine. Now I would like to invite on stage Li Chen of our strategic partner Fastly to talk about how Google Cloud Platform has enabled them to offer a differentiated experience, especially around live streaming, where predictable performance in compute, storage, and network makes all the difference in the world.
Thanks, Jersey. Appreciate it. Hi, everyone. How you doing today? Good. All right. So like Jersey said, my name is Li Chen. I head up cloud partnerships over at Fastly. We're a content delivery network. How many of you are using or have used in the past a content delivery network? A few hands. Awesome. So I spent about 10 years in the digital media and entertainment space working on video games. So that's a pretty exciting space. It was a lot of fun. Appealed to the nerd in me. Grew up playing video games, right? Managing technology teams and working on high-level IT decision-making around there, one of my least favorite things to do was to think about CDN, right? That's like the most boring thing ever. So why am I up here talking to you about it? It sucked, right? Like I was working on really cool stuff, producing live shows, streaming to millions of users, and at the end of every quarter or at the end of every contract period, I would have to sit down with my CFO and figure out, okay, how much am I spending? How much traffic are we pushing? What's my commit going to be? What rate am I going to have to negotiate? What kind of pressure can I bring in order to work this all out? And it was really boring, especially considering that all the stuff around CDN from the 1990s never really came to fruition, right? All the stuff that you wanted to be able to cache, your entire page or dynamic content, really interesting stuff, being able to move and change logic at the edge. That never really happened. These are some of our customers. They use us because we're a different CDN. We are that promise. It's a pretty bold claim. I'm going to spend the next little bit talking to you about why we think that's the case, how we measure TCO, and how we think you should be looking at measuring TCO. Because if you have those tools at your fingertips, the ability to do those kinds of things that I just talked about, and some of the things that you heard from Jersey and from the keynote today, it does actually change the way that you should be thinking about TCO. So first off, we're a different kind of CDN because we're a cloud software-defined network, right? That's a lot of buzzwords all rolled into one. But at the end of the day, what it means is it's our servers in our racks, mostly in Equinix data centers, and they're fantastic. They're going to talk up here in a little bit. And we work on all of the stuff that we build from the ground up, right? We rewrote Varnish, made it our own. It's an open source reverse proxy in case you're not familiar with it. And on top of that, we built an entire routing system to completely optimize how we handle every bit of traffic. We don't use any routers. It's going to be important in a little bit here. I'll explain why. What that allows us to do is see every bit of traffic that's going across the wire. And we let you see that too. So those are really key things. On top of that, we made it all API accessible. So everything that you can do or think about doing on our network, you can do via our API. Our own control panel built on top of our API. So that makes it really flexible. The first thing that we did after we got the platform off the ground was partner with Google. So a lot of the things that you've been hearing about today, and you're going to continue to hear about for the rest of the day, on the left is Google Cloud Platform, right? Nearline storage, the power of compute, being able to leverage containers, easy deploys on App Engine, not having to worry about ops. Those are all things that are living there. Directly connected to the Google backbone is the Fastly network at select POPs around the world. More coming, show you where those are in a few moments. In front of those direct connections is Fastly's Origin Shield. It's a product set which bundles a lot of the different things that are available on our network into Shield POPs. Those POPs protect your origin. They can collapse requests from all over the world down to one location and send that request back across that wire to your Google Cloud instance. It's one request. Anytime something gets asked for, we hold it in cache. If we don't have it, we only go back once, not thousands of times per server, once. And then in front of that is our network. And at our edge is everything else that's available on our platform. Complete configuration control, real-time analytics, the ability to purge instantly. And again, all available via API. So when you have all these advanced routing features and everything available to you, it starts to change the way that you start thinking about things, right? If you can move some of your application logic right over to the edge, you're moving load from your application servers, from where you might be dealing with things in geofencing or mapping to users. It allows you to create custom content sets right at the edge and be able to manipulate those via our API. So as I mentioned, there are 9 POPs around the world where we're interconnected. This is our POP map. So this is every place that we are currently and we will be. The red is where we are today. The little rocket ships that our marketing team designed specifically for me are right up there to indicate where we're tied into the Google backbone. And the blue locations are where we're going to be later this year. So if you take all of that together with Fastly's Cloud Accelerator, the Google Cloud Platform behind it, it becomes the most scalable cloud platform available today. That's pretty key, and again, a bold claim, right? So let me dig into that. The thing that I actually wanted to dig in with you about is how we measure TCO and how I think you should be measuring TCO, right? So if we're going to talk about how you should measure TCO, it's only fair I tell you about how we do it. So if you think about the modern internet, right, or if you think about a CDN, you would think that it's all about how many servers we have in the ground at Equinix data centers or how much bandwidth we've got going into our racks. But on the modern internet, that's not actually the equation, right? On the modern internet, it's more about how fast you can get information or data off of the compute instance or off of storage onto the wire and out to the world. So if you think about it in that context, the CDN is actually about how many IOPS per second you can push, right? Input-output operations per second. So if you're thinking about it in that context, the fact that we use all SSDs, a pure 10 gig network, right? As much RAM as we can possibly cram into one of our machines, it starts to make a little bit more sense why we're architected the way that we are. In order to measure how many IOPS per second we're talking about, we need complete visibility into everything. We need real-time visibility into everything. So you stack that up, we've got visibility, it's fast. On top of that, you need to be able to control it, right? Because you can't actually control your total cost of ownership if you don't have control on it. So that led us to looking at billing in real time, right? So these things are starting to stack up, right? At the end of the day, what all of this ended up doing for us is actually increasing our speed to innovation, right? How fast could we get new features in market? How quickly could we deploy things? So it's a theme that you're starting to hear, or you have heard throughout the keynote and other discussion points that Jersey has had. So said another way, TCO is really about having more control, right? As much control as you can possibly get at your fingertips or at your development team's fingertips. So Matt O'Brien over The Guardian thought about this exactly the same way. They had a very, it's an old company, they've been around for a long time, they have a very complicated stack. In order to be able to extend that technology stack and give the benefits that he was seeing at Fastly to his end users, which is actually his editorial team, as well as his viewership, they needed to tie the CDN directly into the development stack, right? So the net result is Matt's team, or the editorial team of The Guardian rather, is able to actually make changes and have that change on a web page, on a hot piece of content, propagate instantly worldwide. So ultimately, using a CDN or a cloud to Matt and his team at The Guardian was really about getting more control of his app stack, not less, right? If you extend it and you integrate a CDN, you shouldn't lose control of what's happening. If you build on the cloud, you shouldn't lose the control that you had in a colo or an on-prem situation. So let's dig into that a little bit, right? More control, what does that actually mean? So I said earlier, it's about real-time granularity, right? Visibility is really key to that. If you can't see what's going on, you can't make changes. So on Fastly, we leverage the real-time nature of the network to give our customers real-time logs and analytics. This is a screenshot of our dashboard. That data would be scrolling past in real time. You can take real-time logs and aggregate those. If you want to make a change to your configuration, you push that to the API. 2 to 5 seconds later, it's propagated globally all over the world. If you want to cache and validate something, or what we call instant purge, it's 150 milliseconds or less. That is effectively instant. It's the speed of light to propagate that all over the world. Billing, real time. You can see how much money you're spending every single minute with us. But at the end of the day, if you've got all this control and you've got all this visibility, if it doesn't actually perform, it doesn't mean anything. It's not going to do anything for you. It's going to suck, right? So let's shift for a second. These are some of the numbers that we see on Google Cloud Platform. It's a large part of the reason why we've partnered with Google. Sure, it's Google, right? But the consistency of performance is really, really key to that. So you see some of the numbers on Compute Engine and how long that takes to spin up. One of the key things that I've noticed is that a customer that we share with Google, which is Vimeo, they see 8 gigabits of throughput per second on their VMs, on their compute instances. That's tremendous. And they're pushing that envelope really hard. It's lots of video. It's an immense amount of data moving around, and it's sustained at 8 gigabits per second. Coming off of Google Cloud Storage, which Vimeo is also using, 4 times faster than Amazon. On the 95th percentile, and I'll show you those numbers here in a second as well. So at the end of the day, you want as much on the content, as much of your content on a CDN as possible. How many of you are familiar with Catchpoint? Anybody using that? It's a third-party measurement tool, right? Catchpoint does some really great stuff. So we use them to benchmark how our CDN is doing over time. What you're seeing on this graph is milliseconds on the y-axis, and then time span over a series of weeks or days. Lower is better, right? Lower means that we're responding, or somebody else is responding faster and delivering your content from our POP to the end user quicker. But what it's actually showing you is how much content we're holding in cache. So if we're holding more, your cache hit rate goes up. If your cache hit rate goes up, we're hitting your origin less. And it's going to be faster overall. It's going to be a better user experience. What about stuff that you can't cache? Anybody using Sodexis? Familiar with them? A couple of hands out there? Okay. Another third-party measurement tool. This report is public. You can go to sodexis.com/reports and look at it for yourself. This is the dynamic object delivery report. Again, lower is better. This is content that we can't cache. This means that for every request that we get, we have to come back to your origin and get that information, right? Your e-commerce cart, your web server, because the content is truly dynamic or truly unique to a given user. Take all that together, as you can see here, where lower is better, fastest is at the bottom, which is, in this case, a good thing. So here's that graph or the chart I was talking about earlier about performance of S3 versus Google Cloud storage. It's 4 times faster on the 95th percentile. So on the 95th percentile means that 95% of the time, the content comes back this fast. It's 380 milliseconds on Google Cloud Storage versus 1.8 seconds on Amazon. Now, we have a lot of customers who use both Amazon and Google, right? So we have a lot of data to look at. This is a tremendous difference. You think about this in terms of a video load time. 1.8 seconds before I can even take that byte on my network from S3 and serve that to a user. Users typically disconnect from a video stream in 4 seconds. So half of that time is already gone. I have no flexibility to optimize against that. I've lost 50% of my window. E-commerce transactions. What is this stat? It's, for every second, 7% of users disconnect from an e-commerce cart. 380 milliseconds versus 1.8 seconds. It's a pretty dramatic difference. So this is something that we've been sharing on the Google Next tour. Wowza is a live media transcoding platform. Right? So if you've got a live stream and you need something easy to use or you really need robust features, Wowza provides a great platform on which you can scale that, build it out, tune it if you're a broadcaster or just broadcast it if you're a nonprofit. Wowza plus Fastly is being launched on Google Cloud Platform. Wowza actually already has this service available on Google Cloud Platform. They're going to build in front of that Fastly's Cloud Accelerator. So that gives them the ability to scale your stream from 50 users or 1,000 users to millions instantly. The best part about this story, though, is not the scale that they're able to achieve. It took them 7 days to prototype this and put it into production with Google Cloud Platform and Fastly's Cloud Accelerator. 7 days. That was the innovation cycle. We had a conversation at NAB. A week later, they called me and said, hey, we've got it up and running. We're going to put it into production. It's kind of sick. It's pretty fun. Vimeo. How many of you are familiar with Vimeo? All right, cool. More hands this time. I like that. So Vimeo, I don't need to explain what that is. The key point to this slide is actually that it's about focusing your workload in the right place, right? Have your compute instances doing compute. Have your storage actually just storing files. Have your CDN handling the delivery part of it for you. Vimeo built an internal metrics tool, right? So they're looking at video start times and rebuffer times and a bunch of other esoteric information that really only means a whole lot of measurable stuff to video nerds. But it's tremendously important to their user experience and to the brand of Vimeo, right? They need to understand everything that's happening on their network with their content producers and their content viewers. So both of those things need to come together. This tool is critical to the way that Vimeo measures their success. As you can see, the way they divvy this up, they've put 100% of the compute on Compute Engine. Right? So all they're doing on compute, 99% of the time, is just processing the data. They leverage Fastly to deliver the player, and with the player comes a whole bunch of other information around what the player is doing, how is the user experience. It saves them a tremendous amount of money every year. It's an internal tool. They're not using a third party for this. They built this themselves. And the difference between hosting it and serving it on Fastly versus what they were paying a third-party vendor before is a 6-digit number. It's a pretty significant savings. It took them 60 days. Concept, design, build, deploy. It's a pretty complicated stack. Case study up on fastly.com, in case you're interested, on Vimeo, on this and the other ways that they're working on with us, as well as with Google Cloud Platform. So I mentioned this earlier, right? The origin shield that's part of the Fastly Cloud Accelerator. So cache hit rate and how that benefits you. If you are simply relying on the edge of a CDN network, to handle the cache hit rate, you are invariably going to end up with something between 75% and 80%, right? In an ideal world scenario, you might hit 99% for that tracking pixel that you never change. Stuff changes on the internet today. What Origin Shield does by collapsing requests is it allows you to take your cache hit rate from 75% to 95%. 80% reduction in origin, right? So just as a simple math example, if you are doing 1,000 requests per second at edge and you are at 75% cache hit rate, you're going to do about 250 requests per second back to origin. If you're doing 95%, you're doing 50 requests per second back to origin, right? Back to your app server. So first of all, you have a lot fewer requests to handle. Some of our customers are doing in excess of 200,000, 300,000 requests per second. So if you've got that 5x efficiency increase in how you're handling things back at origin, it can dramatically change the way that you have to scale things, right? Not only do you have the benefit of auto-scaling on App Engine or Kubernetes to deploy containers or load balancers on Google Compute, you have a CDN sitting in front of it that is collapsing requests back and handling things at our Origin Shield versus passing all those requests back. So you put all of that together, right? And Harlow Ward over at Hotel Tonight has a great story about this in yet another case study up on Fastly, which I'd encourage you to take a look at. So if you add all those things up, it really means that you can reduce your origin cost by 75%, right? You can really let your teams focus on development, innovation. And that's how we measure TCO, right? It's not just about what's the commit, what's my price per unit. It is about how does your ops team handle it, right? How much load are you putting on them? How fast can you get to market with a new feature? How quickly can you launch that next killer app? And more importantly, what's the performance impact of revenue, right? At the end of the day, that's what we're all held accountable to. How's the business make money? What's my impact to that? So the value of control becomes something that we think about quite a lot. We spend a tremendous amount of time thinking about that and how that impacts total TCO and how we can pass that benefit back to our customers and our end users. So we've got a booth outside. If you've got more questions, I'd be happy to answer them. Thanks very much for your time, everybody.
Thank you. Thank you. So thank you to Jose and to Lee for the walk through the compute section. Up next, we've got Craig Box. He's going to take you through networking, which is the second of the infrastructure sessions. After that, we'll take a quick break, bio break, take some coffee, and then after the break, we'll come back and do the more visual elements of the afternoon session with big data and with cloud ops. So I'll ask Craig to come up and take you through networking.
Yes, thanks, Adam. Good afternoon, everybody. My name is Craig Box. I'm a solution engineer on the Google Cloud Platform team based here in London. And today I'm going to tell you about Google's cloud networking. First of all, I would like to point out that networking underpins everything that we do. Every service we provide sits on top of Google's networking stack. And to tell you a little bit more about that, I'd like to show a quick video from one of our product managers on the cloud networking team.
So for us, cloud really is the baseline. It's how we think about services. It's how we've evolved as a company and how we've built our infrastructure for internal Google services and for our users. Cloud Platform really is for us a way to externalize those sets of capabilities and innovation and make them adoptable by our customers. Cloud today is still in its early days from a technology development standpoint. I think one of the things that's really important is to look at the track record of innovation. When you're choosing a cloud, you're making a long-term commitment to innovation. Right? What kind of capabilities am I going to have in a few years to solve my problems then? It's important not to solve for the problems that you have today, the ones that you don't know of tomorrow. And I think one of the things that we bring to Google Cloud Platform is an unconventional approach to innovation. One where we're going to continue to push the boundaries of technology, redefining the way our customers are consuming technology, taking away the hard work, taking away the unnecessary work, and providing them with capabilities that enable them to redefine their businesses. we really realized that our users wanted fast services. They wanted responses that were virtually instantaneous. And we realized that there was a direct correlation between how users were using our services and consuming our products and how fast we made them. Right? And so we've had this focus on speed above all else for the life cycle of Google. And so the experience has to be ubiquitous across the board, right? It has to be accessible everywhere and it has to be fast everywhere. And that's one of the things that's driven us to build the infrastructure that we have and invest so much in networking. If you look at the traditional enterprise data center of a decade ago, you had to start with what do I need? How many machines am I going to need? Well, then you buy the networking equipment that you need. You go get your enterprise network operator to give you the bandwidth you need between locations. Now you have this capability with cloud of actually having this kind of infrastructure on demand. Right? Not only is it there on demand, but it provides you with a set of capabilities that's very hard to replicate on-premise. That kind of bandwidth, that kind of throughput, that kind of scale, available not just on demand, but instantly. As we grew, as adoption of our services has grown with users anywhere around the world, we continued to make those investments, either in submarine capacity to reach users on the other side of an ocean, but also by building out our footprint, by building out and getting closer and closer to our users so that we could guarantee the best performance possible for them. That footprint now is an asset for our cloud customers, not only because they can deliver better services to their users wherever they are, but also because if you're an enterprise and you now need to get connectivity to your cloud environment, you can find a partner or a service provider that is capable of helping you get connected to our infrastructure. You can do so in over 70 locations around the world. Choosing Google Cloud Platform really is a commitment to innovation for your business. It's being willing to embark in the transformation of technology and how that's going to enable you as a business to continue to grow, scale, and evolve as your business needs.
Thank you very much. So as Morgan said, over the past 15 years, Google has not only been building out a world-class compute infrastructure, but also one of the fastest, most capable network infrastructures anywhere on the planet. So it's not often that user experience and computer networking are really considered together in the same breath. As we've said, Google sees speed as a core feature. If an application gives you instant feedback and the user feels in control, that delivers the best user experience. Studies show that if your website or your application is even 250 milliseconds slower than a direct competitor, then customers will choose that instead. Networking is core to this expectation. It's an expectation that users are going to take forward. And networking is often an unsung hero. If the network is fine, no one cares. Everyone just assumes that that's regular state. And if you don't acknowledge its presence, you will acknowledge its absence. If there's any degradation in network quality, this is something that will be very visible and very important. Users have come to expect twitch-fast latencies. For example, we pioneered instant search, which gives you results as you type, real-time interactions in a Google Doc, or an Uber car inching towards you on your mobile app. All of these things depend on a world-class, worldwide network. So our commitment to speed and availability is a well-publicized story. But what we don't say as much about, and what is of most interest to you, is how your companies can benefit from the investments that we have made in networking. So from Yurjay's session, you will have seen some of the foundational research that we've published in computer science over the last 15 years. You've heard probably about the custom compute hardware that we build. What we haven't traditionally talked about is the custom network hardware that we build. So we build these warehouse-scale computers running things like the Google file system and pioneered being able to query and index on multiple machines using MapReduce. For that, you need to guarantee that any machine in a cluster is able to connect to any other machine in the cluster and access that storage as if it was mounted locally. Now, it turns out that when you start building clusters of commodity machines at the scale that Google built them, there is no network vendor who can build you a switch that's big enough to do that. So here's something that you wouldn't have been able to see if you'd come to our events in the US last week. because our senior networking fellow Aman Vedat presented at the Open Networking Summit in the US last week, presenting for the first time some of the internal technologies that we use for inside our data center. These technologies power the Google Data Center network and allow you to have virtual machines that can be live migrated from one machine to the other, showing no effective downtime. They power fast network-attached SSDs. And just to give you one specific example, this you see here is a Jupiter switch. It's our 5th generation of data center switching hardware. The first Ethernet switch I had at home was probably 4 or 5 ports and about 10 megabit. If you're quick, you can count how many ports there are there, but that particular switch is 4 million times faster than the first network switch I had at home. It is a 40 terabit network switch. And as Greg mentioned in his talk this morning, we connect these switches together into a switching fabric, which has a throughput of 1 petabyte per second. It's hard to pin down exactly what the in-use bandwidth on the public internet is, but best estimates suggest that it's around about 200 terabits per second. So this switching fabric inside one of our clusters can move 5 times the amount of traffic that's currently being exchanged on the entirety of the public internet. It is enough to connect 100,000 physical servers at 10 gigabits per second. No one else has these. Now, it's great to have your computers be able to talk to each other very quickly, but you also need to be able to connect to your users in the world. Most providers build their network for cost. So their goal is to take a packet from their network and hand it off to the public internet as soon as possible and make it somebody else's problem to deliver that at somebody else's cost. That's basically called hot potato routing. We don't want to have that packet. We'll give it to someone else to deliver. Google's network is built first and foremost for speed. So we have a global footprint of points of presence. We have over 70 locations in 33 countries. We keep internet traffic on our reliable private network to as close to the user as we possibly can, wherever they may be, even in locations that other providers don't normally bother targeting, like South America or Africa. One of the first advantages of this system is that your TCP connection from a client terminates at one of these POPs, and then we can aggregate requests back to our data centers. So this is a reduced round-trip time. You can get an increased perceived speed of user connections. Using this network, you can provide global load balancing. Traffic will come into the nearest location using Anycast, and then will travel on Google's backbone to wherever the nearest data center happens to be to serve that request. And on top of that, we run edge caching in these locations. So if you have hot, popular content that you mark as cacheable, we don't even need to go back over the network to serve that. We can serve it directly from those edge locations. Now here's some more breaking news that's happened in the last week. This is the landing of the faster Trans-Pacific cable in Shima, Japan. This is a 60 terabit per second submarine cable that a consortium, including Google, has landed in order to provide more bandwidth across the Pacific Ocean. It's an initial capacity of 60 terabit per second with the option to upgrade. So what you see here is on the left, there's the ship that's been dragging the cable. Its line sort of suggests its path to the shore. And then there's a small building that has the networking gear, it's a miniature data center, if you will, for power and optical equipment at the end. This is just another example of the scale of the network that we run and the investment that we've put into it. Now, if you operate a large public network of your own, if you have an AS number, if you don't know what one is, you don't have one, and if you are present in one of these locations already, then you can get direct peering with Google. So the two connectivity options, this is the more complicated one. For large carrier networks, large businesses, they're able to peer at any one of our points of presence. And as we say, 70 points of presence in 33 countries. Alternatively, we have a great ecosystem of people who will handle doing this for you. So with our carrier interconnect product, you can buy guaranteed bandwidth to Google's network from a large number of carriers and data center providers around the globe. Here are just a few of our service providers, colo providers, carriers around the world. And in a moment, we'll invite Shane from Equinix to tell you about their offering. So let's talk briefly with a customer case study of live streaming video. Today, 64% of all internet traffic is video. On mobile, it's 55% of the content people consume. We estimate that within 5 years' time, that could grow to perhaps 80%. According to Frost & Sullivan, pay TV operators lose $1 million per month for every month they don't offer online video. Think about that. Media companies typically have to spend as much as $1.5 million to set up on-premises live video processing. And this is just to meet table stakes. This isn't something that will set people apart. It's a requirement that all of these people now have. Everyone expects this to be available. So Aventus from iStreamPlanet is a fully managed video streaming service that runs on Google Cloud Platform. So they take the hassle out of transcoding video into the multiple formats for the devices we all consume video on today. Direct peering with Google gave iStreamPlanet a private connection to Google's network. And they can directly connect content owners' broadcast streams to their service running on Cloud Platform. And then our Edge network enables easy distribution of that finished video, whether directly to users, via YouTube, or via a CDN such as Fastly. Another related example, Framestore are a London company. They're an Oscar award-winning visual effects studio who've worked on films like Avatar, Gravity, and Guardians of the Galaxy. They found themselves running out of capacity on their internal compute clusters. Now, their ISP is peered with Google Cloud Platform, so they're able to burst into our cloud. They can take advantage of our sustained use discounts, our per-minute billing, and preemptible VMs. They quickly distribute their source files from their local NFS servers to up to 15,000 cores at peak for their rendering jobs. They render the frames, and then they can bring them back down and analyze whether they got what they wanted very, very quickly. So thank you. I'd now like to welcome Shane Guthrie from Equinix to talk about Google's Cloud Interconnect solution.
Thanks a lot, Craig. I appreciate it. My name is Shane Guthrie. I'm with Equinix, and I'm really excited to be here today to talk to you about what a lot of enterprises are doing and the visions that they have for connecting up to the Google Cloud Platform using GCI at an Equinix facility. In this session, we're going to focus a lot more on how enterprises can use these components to help transform their IT strategies and implement a hybrid cloud solution on Google Cloud Platform. So let's start a little bit by talking about what the platform Equinix vision is and two of the interconnection strategies that we have that are helping the enterprises do these transformations. So what is platform Equinix? First of all, this is how we describe our globally interconnected data center platform. We started in 1998 to help with settlement-free peering amongst various ISPs at the Tier 1 level. As a matter of fact, our core founding attributes are an actual amalgamation of our name. So equality, neutrality, and internet exchange. These things all come together to make the word Equinix, and they would have helped us to attract over 1,000 carriers to our platform over the past several years. We operate 105 facilities in over 33 metro markets with about 4,750 plus customers in those markets. Many of them enterprises, a lot of them great partners like Fastly who enable services within our facilities. And we have a history of operational excellence. Last year we had a 6.9 operational excellence record. That's almost near real time, near constant uptime. And we're also a green data center provider. We explore a lot of things for energy efficiency as well as exploring alternative energy types into our data centers. This allows us to have a lot of facilities that are silver and gold LEED certified. And a lot of them actually operate at a power usage effectiveness of 1.13 or less. So that's almost a very flat utilization of energy across these facilities. But why does this all make Equinix the right place for a lot of these enterprises to meet the Google Cloud Platform? Because as Google was showing, there's a lot of different places that you could interconnect with Google throughout the globe. So first and foremost, one of the reasons that this is really effective for us is we build in targeted metro areas that enterprises already use to consume or even sell their services to the internet at large. And this makes sure that there's a constant flow of new business opportunity in and out for those enterprises into our facilities. And second of all, leveraging upon that, our location and interconnection historical capabilities and heritage help us to amass a dense and vibrant interconnection ecosystem that is proximity-based in those facilities. To that effect, we have 100% of the Tier 1 routes that are announced in between ISPs available in all of our peering fabrics globally. Many of those 1,000-plus ISPs have core nodes sitting in our facilities, so you can have direct access to their cores from our facilities. We have 145,000 cross connects. Those are physical cross connects. That's not even counting the panoply of virtualized connections that are happening through our Exchange fabrics today. And this has enabled us to build a lot of really cool specialized ecosystems. First, we started out in the finance industry, enabling algorithmic trading and exchange setups so that customers could speak very quickly and do financial transactions. Then we moved into advertising, which allowed real-time bidding on ad material and profiling and everything else in a sub-second accuracy. And then also distribution of large assets, large advertising assets like video rolls, through partners like Fastly and other CDN providers. So it's really transformed the way a lot of these advertising bidding ecosystems have come. Same on the media and entertainment space. We're helping to transform not only the production side, where people who are doing rendering and other types of high bandwidth, low latency activities, and also on the distribution side, so being able to take those assets and distribute them directly instead of having middlemen doing a lot of that distribution. Both in broadcast and feature production, by the way. And then now we're focused upon clouds and how do we bring cloud infrastructure together into those same connections for our customers and allow them to explore the different services that are available to enhance that experience. So simply put, Equinix is at the nexus of interconnection between enterprises, clouds, and the networks. Together with Google, we provide a direct private interconnection fabric so that people can actually have reliable connectivity into the Google Cloud Platform that they can actually do real business over. While Platform Equinix provides a natural foundation to optimize this type of access, it also helps a lot of enterprises in other ways too to increase the security, flexibility, and basic cohesiveness of their hybrid cloud architectures. So there are two key topologies we'll talk about here. The first one is our Performance Hub technology. This has been around for quite a while. A lot of people have used it to aggregate all of their networking through a centralized point within an Equinix facility or multiple points in multiple metros in Equinix facilities. And there, they can actually do things like policy application and data policy as well as security policy at a single ingest and egress point to their network. So this allows them to run a completely private infrastructure on the back end to service all of their enterprise data centers, the remote offices, and other facilities, but then actually touch the internet at the closest point that they can to peer directly with service providers over the Exchange fabrics so they can hand their content directly off to those providers instead of having to go through a bunch of intermediary transit providers. And it also gives them now the closest ingestion point and egress point for Google Cloud Platform and their infrastructure. So they can place their infrastructure in close proximity in the same facility across an interconnection to the Google Cloud Platform and the various services that they want to use utilizing GCI. Depending upon the use case or workload, you can also spread this out into regional gateways, so you can have multiple gateways based upon your country of origin or based upon trying to get to various services that you would like to have. And then another cool thing is this allows you now, by having a centralized hub or nexus for all of your data going both to your networks and to the Google Cloud Platform, so you can get your gateways under your enterprise's control. So that means you can actually take your infrastructure that's being, or your various product that's being developed in Google and point it out of your gateway in an Equinix facility. And this gives you the ability, again, to apply those policies and everything else to the interaction with your Google Cloud infrastructure. And it also allows you to do things like ensuring that you can do system management from a central location that controls both your internal infrastructure and your Google infrastructure, traffic optimization, logging, centralized logging facilities, traffic analysis, attack mitigation. So the ability to actually take and take your service flows going back and forth to Google Cloud Platform and then apply capability onto those service flows is something that is unique to this type of product. Performance Hub will give you full command and control of your network, security, and public cloud service platforms. And then one other great thing that's sometimes failed to mention in these types of infrastructures is being able to utilize this hub as a way to get your data out of other cloud platforms and into Google Cloud Platform. Too much, I saw some presentations earlier that were talking about lock-in, where customers feel like they're stuck in a given cloud because they generate so much data and they don't know how to get that efficiently and feasibly out of another cloud platform and into Google. And so now, by having this kind of centralized point, you can actually move that data in between those clouds very easily and very rapidly at high bandwidths and low latency. The second topology I want to talk about is Cloud Exchange. Cloud Exchange is actually a companion to Performance Hub, or it can be a standalone strategy for interconnecting up to Google. Just as Performance Hub is really kind of a physical world extension of your enterprise WAN edge and an ingress point for Google, the Cloud Exchange is actually that in a virtualized box, where we can actually help you run services for interconnecting not only into Google, but interconnecting into other SaaS or service providers as well. This allows you, like I said, to do workload transformation or translation, and it also allows you to use other cloud services that you may subscribe to in concert with your Google Cloud Platform, so that you can get data into and out of GCP for various things of interest. So say you have a Salesforce platform and you want to be able to get data out and do analytics on it in GCP. That's what this type of fabric would allow you to do. It is the real culmination of over 17 years of lessons learned with us running high capacity internet exchange, Ethernet exchange, and other types of virtualized exchange fabrics. It's programmatic, it's controlled by APIs, it is a carrier class, constant availability interconnection fabric. It can run virtualized networking functionality such as routers, VLAN switching, as well as things like network address translation. Speaking of network address translation, all of our customers that are going into and out of GCP, we do translate those addresses on your behalf. So that allows you to do things like bring your RFC 1918 space into your Google Cloud Platform topology without having to do things like build IPsec tunnels and take the associated performance hits that come with that type of topology. It eliminates shared, often congested public peering points. As Craig was talking about earlier, a lot of times your traffic is hot potato tossed around on the internet. This allows you to make your connection to Google Cloud Platform predictable. It allows you to take those enterprise class applications that you want to utilize and have a reliable element in the middle, so that you know how it's going to perform, and you know the bandwidth that's going to be allocated to you, and you know that if you buy a certain amount of bandwidth, you're going to get that amount of bandwidth. This is really critical for a lot of your critical applications that you're deploying today. The SDN capabilities of our ECX platform and those APIs that I was talking about earlier allows you to actually provision services on demand. So once you're physically connected into that port, you can raise or lower your bandwidth commitments to that port for a given service. And this really helps you to control your cost going back and forth on, at different times of day or even different times of the month for different types of workloads that you may want to go across the fabric for. It allows you to take and consume multiple services over a single port. So this is really, really handy if you're going to have multiple SaaS services that you're consuming, as well as Google Cloud Platform. This allows you to have all of that into a single place, not only that you can apply policy, but that you can monitor usage. And at your edge gateway, you can also apply different QoS schemes as well, so that you can control the interaction back and forth and ensure that your GCP is not interfered with by other kind of connectivity. In essence, it's really a software-controlled cloud traffic fabric or exchange that gives you an enhanced path into Google Cloud Platform that avoids the open internet. So we've been working with Google to deploy in over 15 markets, and we're very, very happy about the footprint that we have. Those enterprise markets were chosen because they were really the top markets that enterprises wanted to be in to be able to interconnect and get all of their services from a single fabric. This physically allows them to place their infrastructure in close proximity to Google instead of having to rely upon the tiebacks or transit connections that they have all the time, and allows them to change the way that they consume their normal enterprise data center topology and move to things like Metropolitan Ethernet or on-demand, on-net type of access. This proximity allows us to get an average performance increase of about 28% across the 15 sites over what you would normally get through an internet transit gateway. And it reduces the number of hops to GCP by an average of 24%. So you're reducing that hop count of how many hops your packet has to transit to get in and out of GCP. This is really, really representing a large possible performance gain, especially when you're talking about data-intensive applications. On top of all of this, again, if you take out the factor of having to build an IPsec tunnel for your RFC 1918 space, typically you lose about 30 to 35% overhead on the encryption for building those types of tunnels. So you can really start to see where these performance gains can be really, really handy. That's really most of what I have for you guys today. I'd like to encourage you to come by the booth. We have a great application that's available in the Play Store right now that actually uses the Google Cloud Platform and shows some of the scale-out capabilities. And it's also a lot of fun to play. It's called Cloud World. And we'd also like to talk to you about how a lot of these technologies and capabilities can help you to transform what you're doing today with your infrastructure, improve the efficiency, help you with security, and come up with some new ways of deploying applications that we think are really transformative in the industry. Thanks so much. Appreciate your time.
Thanks, Shane. Okay, so we've reached the halfway mark. Well done. That ends the infrastructure part of the session. So we've covered compute with Jose, networking with Craig. Thank you to Fastly and Equinix for coming up and sharing their stories as well. They both have booths out the back. We're going to break until 3:15, so please take a bio break, grab some coffee, something to eat, and we will start back again with big data and a lot of visual stuff at 3:15. Thank you. Okay, welcome back. So the last two sessions of the day are going to be very interactive. We've got live demo for both sessions. We're going to start off with big data. Philippe and his crew are going to take you through the big data solutions, talk a little bit about storage. Got some great demo to show there. Tableau is going to come up on stage and show you some of their stuff in action, which is pretty cool to see. And then Dan's going to come up, talk about operations with cloud monitoring and cloud logging. And his is a very demo-heavy session. There's a couple of slides to set things up, and then Dan's going to spend most of the time showing you this stuff live in action. So without further ado, I will hand over to Philippe to kick off the big data session. Welcome, Philippe.
Thank you, Adam. Hi, everyone. My name is Philippe Poutonnet. I'm responsible for big data and storage product marketing at Google. Very excited to be here to walk you through our big data product and services, but also to kind of like walk you through our principle when we built a big data product. That's really something that we really want to share with you. I think you've heard that the entire day. Very quickly before I go through this presentation, I just wanted to share one stats with you guys, because I'm going to refer to the statistics many, many times during this presentation. And this is a stats that I got from a Gartner report, where they basically interviewed 300 executives all around the world about where they're at with their big data deployment. And the survey says that only 13%, 13% of enterprises in the world have some kind of big data deployment or big data, that they're using any type of big data. So the reason why I wanted to share the stats is, first of all, because it's very small, and everybody should know that. And also because so much being said, so much being written about big data, I feel like when I talk about big data, I feel like everybody should know about everything and should be doing it, but really it's only 13%. So our goal is to make sure that we share with you our principle, our vision, and this is basically what I'm going to talk about today. So very quickly, you've seen this slide. We're going to talk about our big data products that are a BigQuery, PubSub, and Dataflow, but also walk you through our storage products. The reason why we going to talk about both of those products is just because they're so connected that we can't talk about one without the other. Video, the internet, mobile, Internet of Things, all those digital revolution, I think we've talked about it, are generating a humongous amount of data. I think we all know that. IDC says that the size of the digital universe is actually doubling every year. The Internet of Things will be a major contributor. IDC says that there's going to be close to 32 billion IoT devices that will be connected, generating 10% of the world's data by 2020. A good news is the fact that a lot of that data will move to the cloud. 40% of all that data will be touched by the cloud in 2020. It's actually inevitable. There's just so much data that the way enterprises on-prem storage are set up, they just cannot handle all that data. So we're going to see a shift to the cloud according to IDC, and we definitely agree with them. So lots of data brings, of course, a lot of problems. And Greg talked about it this morning. The way big data is actually offered to you today is just basically bringing a lot of problems, and unfortunately not a lot of solution at this point. The first one is big data is really complex to build and set up and maintain. And another thing is the fact that capturing and storing all that data is also another problem. How do I aggregate all that data and bring inside my system? And also, I'm accommodating for all that data. We say that the size is doubling every year. How do I accommodate for a database that is being multiplied by 2 every year? Finding value in all this data very easily. It's not only about getting this data, analyzing it, but I need to find value, and I need to find value in this data very quickly. Iteration on big data. This is something that is really, really important for us, and I'm going to go back onto this point. Make sure you can iterate on your data very fast. Another point which I think nobody really talks about, and you guys need to think about it when you think about big data. Big data is not only for 1 or 2 people in their company. You need to basically analyze your data and share it with everybody. Once you've processed that data, once you've analyzed that data, you need to share those reports with sales, you need to share it with marketing, you need to share it with the CFO, the CEO, and also you need to make sure you have the right permission for all those people. You don't want to send, a report to HR, to marketing, and vice versa. Everybody should have the right permission to the right file. Of course, keeping your data secure and make sure your system, is reliable and keeps on running. So that's a lot of problem. The good news is at Google, we've been trying to solve those problems for quite some time. For over the last decades, we've been building products to solve all the problems that I just mentioned to you. And I'm not going to go through all those products, but I'd rather talk to you about what type of problems those products have solved. Google search today is processing 3.3 billion searches a day. It needs a big database to do that. YouTube, there's 300 hours of videos that are being uploaded every minute, 300 hours. And there's 425 million of people right now using Gmail. So anyway, the size is just massive, and we've built all those products to make sure that we can handle all those big data and the processing capabilities. So what do we want? We basically, when we build big data product, we want to move you from the left side of this slide to the right side of this slide. When I talked about the fact that right now big data is too complex, there's too much things to do, it's just because there's all those different tasks that you have to do. You have to do the programming, resource provisioning, the deployment, the configuration, and we briefly talked about it this morning during the keynote. People spend more time on building their infrastructure, and they don't spend enough time looking at this data and basically taking action on their data. We want you to focus on insight and not infrastructure. We want you to be on the right side. Work on your programming very quickly, and then focus on insight. So how do we do that? So we got 3 main principles that we inject in all the products that we develop. The number 1 is the ease of use and setup. And I'm going to put some emphasis more on the setup, just because if I go back to my stat, only 13% of enterprises are doing it. A lot of companies have a really big time setting up their system. So every product we built is fully managed. You don't have to hire an army of DBAs, of engineers. Your analysts can actually set it up and get it running. Ease of use and setup. The second principle is this notion of speed of iteration that I just mentioned earlier. So what does that mean, speed of iteration? When you're going to start using any type of big data product and you're going to start looking for the needle in the haystack, most of the time you're not going to get it right the first time. And I'm pretty sure you're not going to get it right the second time either. If you're lucky, you're going to find what you're looking for on the third time, but with the conversation I have with some of my clients, it's never going to happen. So what we want you to basically fail really fast to be able to succeed even faster. That's what we mean by speed of iteration. Fail fast to succeed even faster. And then you're going to be able to just play with the data, run some queries. Run a query, you're going to see a demo of BigQuery. Run a query against 100 billion of rows in a matter of seconds instead of hours, and that way you can do that many times, and voila, you're going to find what you're looking for. And the third principle we also inject in our product is this notion of low TCO. And we don't do that only by trying to provide you the cheapest product, the best bang for your bucks, but it's this notion of fully managed service and product that we offer to you, which basically going to reduce the amount of people that you're going to have to hire to do your big data. If you're a gaming company, you should be focusing on developing application and not developing your infrastructure. And if you're a retailer, same thing. Focus on your business. Don't focus on building a system. So 3 things. Ease of use and setup, speed of iteration, and low TCO. That's what we want for you. So before I hand it over to my colleague, Rez, who's going to walk you through more into detail about our product, I just want to walk you through a couple of case studies, companies we work with that they both had 2 different problems that got solved by some of our products. First company is SunGard. SunGard is a multi-billion-dollar financial services company that I would qualify their problem in the matter of size. They basically had a 100 billion market event, 100 billion rows that they had to ingest in a 4-hour window. And on top of all their existing data, which was around 30 petabytes, and making sure that their database was also scaling, they basically had data that was growing at 25% year over year. And they wanted to make sure this data was queryable immediately. 100 billion rows, scale, 30 petabytes of existing data, querying immediately. And basically, they're using Cloud Bigtable to solve all this problem. Cloud Bigtable is our recently introduced NoSQL, petabyte size database that all the major Google products run on, such as Search, such as Map, such as Gmail, and Google Analytics. Another company I wanted to talk to you about is DNA. DNA is a gaming company, Japanese gaming company, and their problem was not really on the size of the database, but more on the speed. They wanted to basically ingest all their data, their real-time data, stream all their data really, really fast into a database and being able to query this data at even faster rate. But also this notion of that I just talked to you about, being able to run those reports and share it with the entire organization really fast. And Google Cloud BigQuery was perfect for them. With BigQuery, they could stream up to 100,000 rows per second, have this data automatically queryable, and being able to share those reports with analysts inside the organization. They used to use Hadoop. They had lots of problems with Hadoop. It was really slow. As soon as it transferred, they basically saw immediate speed increase, increase in ROI, lowering your TCO, because also they didn't have to break the bank. So I'm going to have Rez come over and basically walk you through all our suite of product. Thank you, guys.
Thanks, Philippe. Hey, everyone. My name is Reza Rockney, and I'm the solution engineer covering UK and Ireland. And it's been really nice today to have quite a few of my customers here joining us. Also interesting was listening to James from Ocado talking at the earlier keynote. Some really interesting things that the guys are doing. They're a really interesting company to be working with. So let's break this into 4 pieces, the management lifecycle of big data, and tie that to some of our fully managed no-ops services. Start with capture. And a lot of the customers I work with today are actually doing a lot of their work in batch. And Greg talked about this earlier, about this transition to streaming. A few customers are actually on the streaming journey. Some are thinking about it. And streaming actually introduces some interesting challenges around being able to deal with variable loads, around being able to build out your infrastructure. Of course, with some of the managed services that we have, like Pub Sub API, this becomes easy, an easy problem for us to solve. In terms of processing, again, what the customers are looking for is the ability to have a dial where they can switch between speed versus cost. So if you're doing batch processing, I just want to be able to send a single option that says, get this thing done quicker because it's important to me. Or actually take more time. I want to spend less money on this. And with data flow, which we'll talk about more in a moment, you can actually do that, as well as the fact that data flow is one system to deal with both batch and streaming content. You do not have to build 2 separate sets of technology, 2 separate sets of skill sets to maintain these systems. Then we have storage. And Greg talked about the fact that we're digital hoarders. I think he used the expression. And with one of the things that actually really resonates with the customers is the idea that you don't actually need to provision machines. You don't need to provision instances or plan ahead based on the amount of data that you have. So whether you've got a gig or you've got a petabyte, it should not matter. You should just be able to put the data into storage without having to do anything special. Then we have our analysis. On analysis, I think you remember our friends with the cat. They talked about the fact that they want their data scientists, they just want to be able to use BigQuery. They want to be able to use the processing engine without having data scientists and BI specialists having to do the work for them. But also, for the data scientists, I get lots of times when we're talking to them about the fact that they're worried about the processing that they're running because they're concerned that if they run it at peak times, they're going to get a lot of people from the operations side, from the data warehouses group coming along and saying, hey, by the way, that query you've just run has just cost us a lot of time. So the ability to be able to run these processes without having any problems, the ability to do this without thinking about your infrastructure is key. So let's go a little bit more in depth. And of course, you would have, as you'd expect, we have deep integrations with the Google Cloud Platform products. So with cloud logging and with monitoring, which actually we're going to have the session after me is going to go a little bit more in detail. These logs are automatically getting put into BigQuery. And automatically, you can then run queries directly against them, but also against other services from Google Analytics Premium, for example. With Google Analytics Premium, rather than just getting the aggregated results, you can actually get the detail level, unaggregated data to be put into BigQuery. And you can immediately run SQL against it to analyze what's going on the traffic on your websites, for example, doing things like funnel analysis. Then we have the Pub Sub API. So thinking about the Pub Sub API, it's It's one of those things, like a lot of things in Google, where it looks very simple, but it's actually doing very complex engineering in the background to make it work. So it's a global publish and subscribe API, which allows you to put messages in on anywhere in the world and be able to pull them out, use it from your pipelines to be able to deal with them in real time. And Greg was talking about the fact that we need to get at this data quicker. We need to be able to process, not in batch mode where it's going to take till tomorrow, but immediately as the stuff's happening. If I've got a clickstream of information coming from my website, I want to be able to detect anomalies as it's happening, not the day after, so I can react to it. And then we have the processing. So obviously you can use Spark and Hadoop to do the processing, but with Google Cloud Dataflow, it's actually an amalgamation of two different technologies. One is Millwheel, the other one is Flume Java. And actually, in IT, we all stand on the shoulder of giants. Within working with Google, I stand on some exceptionally tall giants, which given my height is very handy, of course. And I've actually spoken to some of the guys who've wrote those white papers. And I have to admit, it took me 3 or 4 times of reading it, and I still only half understand it. But these guys have put a lot of effort into dealing problems, for example, with streaming, where instead of you having to build out 2 separate systems, as in the Lambda architecture, for dealing with both batch and streaming data, you can do it in one. You can deal with things like late data arriving in a very, very smart way. And to actually see this stuff in action, we've got a demo for you guys. So we're going to roll the video, please.
Google Cloud Dataflow is a unified and fully managed service for big data processing. Its goal is to reduce the time, cost, and complexity of answering big data questions. Cloud Dataflow can be used for traditional batch, aka MapReduce processing like ETL, and computation over arbitrarily large at-rest data. It can also be used to drive real-time analysis over high throughput data streams. The unification of batch and stream processing reduces the development and operational complexity by enabling developers to focus on a single programming model and a common service environment. As a fully managed service, Cloud Dataflow provides automated work life cycle management, dynamic work optimization, intelligent autoscaling, and integrated monitoring, freeing developers and administrators from the burden of allocating, deploying, optimizing, and managing compute and storage resources. Let's look at an example of where you might use Cloud Dataflow. This demo is based on a mobile music scenario where devices report back user actions like what song did they pick to play, and playback events like how long did it take for a song to start playing. This demo models 1 million users driving approximately 2 to 20,000 events per second depending on current usage cycle, addressing 4 different use cases. Specifically, I wanted to reliably ingest all of the raw event data into my database or data warehouse in real time. I want to have my raw event data available for interactive analysis. Secondly, I wanted to calculate the total active users of the system on a per minute basis in real time. Third, I wanted to calculate the total active users of the system on a per minute basis over historical data. And finally, I wanted to calculate some play suggestions in real time over historical data. To answer these questions, a developer would build a Dataflow pipeline using the Dataflow SDK to express their desired computation requirements. Here is the sample code for this demo. I have a pipeline with several branches. We will review some specifics of the code later in the demo. For now, let's get a job running. To start a job, you simply execute the pipeline. The Dataflow SDK will optimize your pipeline graph and submit the optimized graph to the service. The service will then spin up the needed compute and storage resources to execute the job and then start scheduling work. In this case, I am running a stream-based job, reading a continuous data stream from Cloud PubSub. The mobile devices forward events to a Cloud PubSub topic. This topic is globally available and can provide throughput of tens of thousands of events per second. Once a job is submitted to the service, you can view its overall health and processing throughput via Dataflow's integrated monitoring UI. You will notice that this job structure logically maps to the pipeline code, making it easy for developers and administrators to understand the logical execution behavior of the job versus dealing with lower-level compute and resource metrics. Right now, the pipeline is processing roughly 5,000 events per second. The archive transform represents the code I wrote to address some ETL needs for the raw input events. My code then uses Dataflow's BigQuery sync to reliably write all the events to my dataset in BigQuery. BigQuery is a fully managed interactive analysis service capable of processing queries over petabytes of data. It's also capable of ingesting data at 100,000 rows per second per table. Here's a sampling query over the most recent 1 minute of mobile event data. The overall latency is roughly around 2 seconds. This data is instantly queryable. We solved problem 1. Let's move on to problem number 2. Problem number 2 was focused on continuous computation of active users on a per minute basis. To answer this question, I used Dataflow's powerful windowing primitives. Specifically, I used a fixed 1 minute window that effectively groups all of my data into a discrete time dimension. From there, my code does some processing to calculate user counts over event data. I'm writing the windowed output to BigQuery. Let's take a look at that output. This table contains all of the windowed session output. The start and end times represent the boundaries for the fixed window. You can see that there are a little over 162,000 active users in the system for the last fixed window. We answered problem number 2. Problem number 3 is a variant of problem number 2. We want to calculate active users over historical at-rest data versus a stream source. Typically, a developer would rewrite this as a batch-style question in MapReduce and then run it alongside the stream-based implementation. Dataflow's unified API enables seamless transitioning from stream to batch and batch to stream. Here's the code that I submitted for the streaming job. I'm going to change the input source to point to at-rest data on Google Cloud Storage, and I'm going to tell the pipeline to run in batch mode. Now I simply re-execute the pipeline, and we're now processing historical data. Keep in mind that my existing streaming pipeline is unaffected. Same code, same processing model, in batch and stream. We solved problem number 3.
Eric showed us how to stream data into BigQuery with Cloud Dataflow. But how big is that data? Well, we can see by running a query that it's about 169 million rows. Is that big data? I don't know. But one of the underappreciated facts of big data is that it starts out small. It starts out when you start streaming your logs or start collecting your customer data or you launch a new service. And you want to pick an analysis service that can handle data of any size. One of the great things about BigQuery is that it's scale invariant. So here is a query over 1 million rows of Wikipedia data that runs a regular expression over each row and aggregates by language. As you can expect, it doesn't take very long, 1.7 seconds. Of course, 1 million rows isn't cool. You know what's cool? 1 billion rows. So that only took another 2 seconds, but it did 1,000 times the work. But 1 billion rows isn't that large either. At some point, you've got 100 million customers and you want to track them each over 3 years. That's 100 billion rows. Let's see how BigQuery handles it. This is running 100 billion regular expressions over 4 terabytes of data. 6.2 seconds. If you wanted to do that in serial, it would take 32 hours to run that on a single CPU. A single disk would take 15 hours just to read it. So let's go back to the live stream of data from our music players. We can combine this with information that we already have to enhance its value. For example, we also have a table with playlists, which has track level information. Let's run a join query between these 2 tables to add a song and artist information. We can save this as a view so that we can think of this as its own table, but the values will be updated in real time since the input stream is also updated in real time. We might also want to give one of our partners access to this view, though they don't have access to the underlying data. We can do this by sharing the view dataset and adding the view to the ACL of the underlying table. Okay. Yeah, once we have combined these data sets, we can do something interesting with them. Let's figure out which artists are most popular for each hour of the day. We're going to use an advanced BigQuery feature here, the rank analytic function. Show here, which lets us find the relative ranking of each song by the hour. We'll pick the top 3. Note that this is using simulated data, which is why the Christmas song is so popular. Finally, let's use some real data to solve a real problem. If a user likes a particular artist, who else might they like? There are lots of approaches to this, but let's use the following. Given that people often put songs that they like together in a playlist, let's pick the artist that is most likely to follow our target artist in the same playlist. We can come up with a pretty simple query to do this based on the pieces we've already seen before. Let's say we're inspired by B.B. King and want to figure out who else we might like. So this says to try Eric Clapton, Bob Dylan, and John Lee Hooker. Not completely unreasonable. Let's try some another one. What about Dr. Dre? Eminem, Snoop Dogg, 50 Cent, Tupac. Seems like a pretty decent recommendations with only a little bit of work. Now we've solved problem number 4, how to recommend music artists to your friends.
Great. So in that demo, we saw data being ingested through PubSub. And that data could have come at hundreds of messages per second, or it could have hundreds of thousands of messages per second. There's nothing different you would have to do in those two scenarios. That data was then being consumed by Dataflow. Dataflow was processing it as it was coming in. It was also dealing with the fact that when you're dealing with a stream and you want to do things like aggregations, etc., you need windowing. So it was doing some windowing functions. As Eric mentioned, it was a simple windowing function that we're doing there, but you can do very sophisticated things. For example, imagine if you had to have accuracy in that group buys that you're doing in your streaming data. So each window needs to be very accurate, and then a piece of data arrives late, which is a very common scenario when you're dealing with streaming. So with watermarks, Dataflow can actually deal with that situation by putting the late arriving data with its correct grouping and giving you an accurate result. After that piece, we were going into BigQuery and running analysis against it. But we could easily have also had other anomaly detection going on as the stream was happening. So imagine you've got a stream of information coming from your websites. Imagine you've got streams of information coming from the log files that you have in your systems. This stream of information coming from your websites, you want to be able to react to things happening in real time. It's actually trivial to set up a system that deals with the anomaly detection. All of that stuff that they showed, there was no infrastructure installs. There was no disks to worry about. There was no setup or monitoring involved. We take care of that. All they had to do was build their IP, their bit of the code that's their business logic, and that's what mattered. At the end of this, we've also gone through the processing. So now in terms of storage, there's several storage options available. So we've got Google Cloud Storage for files. We've got Cloud Bigtable for NoSQL jagged row inserts. We've got BigQuery storage for tables. What's the right option? And this is actually one of the common questions that I'll get within the first meeting or second meeting with customers, is out of all the options you give me, where should I be storing my data then? Well, the answer to that question lies in what you want to do with that data. So BigQuery is awesome at running through huge aggregated amounts of data. It is fantastic at doing that. What it's not designed to do is quick point index lookup of information. That's what you can use Cloud Bigtable for. Bigtable will be able to store 200 petabytes of data. It is a huge system designed for exactly those kind of use cases. So if you imagine you wanted to create a dashboard that contained all of the pre-aggregated data, but it also contained the ability to drill right down into an individual record piece, Bigtable would be an awesome backend to that system because it can deliver back in milliseconds. We also have, again, BigQuery being put into storage and analysis. Again, back to this idea, the fact that you can store as much as you want without having to worry about the infrastructure. BigQuery that's why we've got it in both places. You use BigQuery to do the analysis, but it can be just used as a standard place to store. One of the use cases that I had from a large financial institution was I want the ability to actually store a huge amount of data that's historical in a place that I can easily access. Today, it just goes out to tape. But in terms of the cost analysis, it actually works out quite well to actually put it into BigQuery, and then you can immediately access this data, even if it's from 6 years ago. If you're not doing anything with it, if you're not running any processing against it, doesn't matter. You're just paying for the charge of the storage, not for machines. Of course, any platform needs a great set of partners, and both service integrators and technology partners. I've had a great pleasure of working with quite a few of the service integrators here. But also on the technology partners, we've got Tableau. Jeff is going to be able to come up and chat to us about this. And the great thing about Tableau is nearly every single customer I speak to is either using it or as currently trialing it or playing around with it, which is amazing. So, Jeff? Thank you.
Hi. Good afternoon, London. How are you all doing? My name is Jeff, and I'm a product manager at Tableau, and I lead our big data product roadmap. I'm delighted to be here with you all this afternoon. So Tableau's mission is to help people see and understand data. This has been our mission statement since day one, and it's still our mission statement today. And this mission helps to drive our product roadmap and product innovation in terms of everything and all the features that we do for Tableau. For instance, we strongly believe that the process for analyzing data is too complicated. That's why we provide drag and drop operations in order to analyze data rather than writing SQL queries or writing code. Secondly, is we believe that users should be able to ask deep analytical questions. That's why we provide a whole suite of analytical functions and drag and drop visual analytics in addition to our suite. And third of which, we believe that users should be able to interact with their data and have real-time conversations with their data rather than static analysis. That's why we developed our software to emulate the cycle of visual analysis, to hop between any two steps in terms of analyzing your data or jumping back to data prep and pulling in additional data sets. So why see your data? So what I'm showing here is an example of an Office Superstore broken down into different categories as well as by different segments. And so can anyone raise your hand if you can identify which is the least profitable segment in this group? Raise your hand when it's up, when you got it. OK, let me just make it a little bit easier. What if I highlight all of the negative profitability segments? Now can anyone get it? Raise your hands. How'd you get them? OK, I see a few more. OK, now let's apply visual best practices to this. Now, can anyone tell me the most profitable segment? Raise your hand. I should see everyone's hands up. OK. So the fact is that humans were designed to understand shapes and sizes and colors and position much more easily than anyone can read a string of numbers. And if you think that this is challenging with this data set, just imagine what it's like with big data, such as data that Google BigQuery can handle. So we believe that Tableau Online is the best analytical tool for Google BigQuery. And it all starts that we provide native integration to Google's BigQuery service. We wrote a connector using the native APIs, which means that we take advantage of the most, we get the most performance out of a connector. And we're able to leverage unique functionality that the Google BigQuery service and APIs offer. And this provides several advantages. First, it supports live interactive analysis against massive amounts of data. And this is really important because nobody likes to consume data or do anything slowly. And in addition, Google BigQuery service allows Tableau and other analytical tools to be able to analyze billions and billions of rows in a matter of seconds, as we just saw earlier. And that means that you can create stunning dashboards within a matter of just minutes. And we're going to show you that later on. In addition, as I mentioned earlier, Tableau has an intuitive drag and drop interface. No more writing SQL queries. And in fact, you don't have to write any code whatsoever. And this is really important because that means that it expands the usefulness of data to everybody within your organization, to all of your knowledge workers. It democratizes the ability to analyze data and makes it really simple for anyone. That means that your person in marketing who is looking at social analytics, social media campaign, can be able to tell who are their most engaged users really easily. It means that person on the factory floor can look at their operational data of the factory and understand why at noon production seems to slow down. This is really, really huge. And in addition, Both Tableau Online and Google BigQuery are both cloud-hosted solutions. That means there's nothing to manage. It's zero-side, server-side management. And that gives businesses the agility and the flexibility they need to be able to scale with their organization's needs. And furthermore, for the people in IT, it allows them to be able to work on more strategic projects, such as the overall IT architecture, or managing scalability and security for the organization, bigger, higher impact items rather than just managing boxes. And last but not least, we believe in Google's vision for the cloud and the technologies that they've brought to the market. And we believe that it is the future. And to add to that, today, you guys are the first to hear that we've just released a new connector to Google Cloud SQL. And this is in addition to our existing native connectors to Google Analytics and Google BigQuery. And we've added the Google Cloud SQL connector because we really believe we want to give users options, for both hosting as well as analyzing data in Google's cloud. And so we're really excited to announce this. And so we're going to continue investing in our integrations with Google, and we're excited to be a partner of theirs. So I've got a really awesome data for you guys. Who in here likes Twitter? How many of you guys have tweeted this morning? OK. So what we've done is we've worked with our friends at Twitter Dev, and they've developed an open source connector that allows them to be able to push data from GNIP, which is their enterprise API access for providing filtered tweets to different systems. So we're streaming tweets into Google BigQuery. And then from Tableau, we have a live connection into Google BigQuery to show visual insights. So this is going to be really cool. Can we switch over to the laptop? So first, what I'm showing here is about 3 weeks of data of tweets. And from Twitter, what we did was we searched for tweets that had things that included like hashtag big data, hashtag Internet of Things, @Google, and other search terms. And so what you see here in green is essentially any tweet that does not contain the word data, and anything in yellow is something that does contain the word data. Oops. 1 second. I'll just wait for a minute to come back. And so essentially, this dashboard was created in Tableau Desktop, and then it was published up to Tableau Online, which is our hosted analytics solution. And so Tableau Online is great if you don't want to own the underlying infrastructure, and if you just want to have greater agility for your business and for your organization. So let me just give it 1 second here to refresh. And so what you can see here is now that I've refreshed it, oops, let me see if I can zoom in. I'm going to type in GCP next. And you can see that there's several spikes here in terms of around June 12th, June 17th, June 18th, and June 23rd are spikes where you see more hashtags of GCP Next. And that's because those align to the 4 events that we've had so far on this tour. And what we could do is let's analyze the data that's from this particular event. So instead of 3 weeks, I'm going to go to 3 days. And remember, this is live streaming from Twitter over to Google BigQuery. And you can see there's a fairly large spike in terms of activity of GCP Next. And what I'm going to do now is I'm going to filter down to just the GCP Next tweets. So let's see what people are talking about. Let's get ready for tomorrow's GCP Next London, a very cool venue. That's true. Hope this will be interesting. Let's see what else we come with. Google Cloud Platform Next events. So yeah, these are very, very current tweets. OK, so now let me show you, give you a look under the hood as to what's going on. So I'm going to click on Google Next. And I'm going to click on Data Sources. And so currently, I'm connected to this thing called Tweets. This is a table called Tweets GCP Next. And as you can see, it's live. I'm going to click here. And now I'm going to create my own new workbook. So now we're going to build a dashboard from scratch. And as you can see on the left-hand side is the list of dimensions and measures of the full schema coming from Twitter. And Tableau automatically detected what's a dimension and what's a measure. And so now we can begin asking questions over data, such as how many tweets are we dealing with? So I'll double-click number of records. It'll run a query in the background. And there's about 2.3 million records in this data set. Not big data, but it's not small data either. Now we can ask additional questions, such as, what are some of the hashtags that are trending with this particular stream of tweets? So I'm going to grab hashtags, drag it to the column shelf. Fairly easy enough. It runs a select statement with a group by in the background. And what I'll do is I'll swap the axis. And I'll do a sort. And we can see there's a lot of people tweeting about Google, about Android, some about Apple, and news and others. This is great. So let's shift the focus over to the people tweeting. So instead of looking at hashtags, let's see who are some of the most active tweeters. I think that's what they call them. So we run another query. And I just love using this combination, Google plus Tableau and Twitter. It's three technologies that I really love. We'll do a sort. And on top of that, I'm going to apply a filter. So instead of the 3 weeks of data, I'm just going to filter it down to just the last several days. So let me see if I can find it. Posted time, drop on the filter. So literally, within minutes so far, I've been able to create a couple different views of the data. It gives me the freedom to be able to explore the data and focus on things that I want to look for, rather than worrying about writing SQL queries. So now I'm going to change this to a relative date filter. I'm going to analyze the last 3 days. And some of you guys might even see yourselves in this data set. Let's take a look. And if you see yourself on this list, just raise your hand. Well, the main point is that this is a great solution for being able to analyze real-time data. I'm really excited about it. What I'm going to show you is one more visualization here. Everyone likes geo information. So let's say we want to analyze location data. So what I'll do is I'll go over here to location, country code, and you'll see there's a little globe symbol, which means that Tableau's automatically detected that it's a geo field. So I'm going to drag that onto rows. And now we see that people are tweeting from all different countries. And now, since I know that there's a lot of null data, because within Twitter you don't have to specify where you're located, I'm going to go ahead and filter out the nulls. Remove it here. And then the last thing I'm going to do here is I'm going to display what's the total number of tweets based on size. And remember, every single one of these actions is driving a query in the background. I'll blow it up a little bit so you can see it. And just for kicks, I'm going to drag out the color as well so that you see more of that contrast between where people are tweeting from. And you can see that's a lot from the US, some from Canada, and a good chunk from the UK as well. So let's switch back. So we believe that Tableau plus Google BigQuery is an amazing solution. Together, the solution provides fast, easy, and beautiful self-serve analytics for anybody. We're really excited about the solution, and we're going to continue to invest in it going forward. Oops, clicker. So if you want to learn more, Come out to visit me and my colleagues, Bob and David, who might be sitting in here. We're just across the way in the partner lounge. And if you'd like to get your hands on Tableau and try it out for yourself, you can go to this URL. Oh, shoot, it's still Tokyo. OK, just swap out Tokyo for London. You can go to this URL and get an extended free trial for you to try out yourself. Thank you very much for listening.
Thanks, Jeff. Nice job. OK, I'm just going to ad-lib for a minute. We're just going to swap over some machines here. Dan's going to be largely doing demos. So thank you, Philippe. Thank you, Tableau, for coming and doing some great demo there. So for those of you out there in the audience, I hope you're getting some value out of today. Put your hand up if you learned something new today in one of the sessions. All right, that's good. Everyone's learning something. That's a good start. What's your favorite session been so far today? Yell out some topics. Compute, network, keynote, big data. Big data? Compute? Good, excellent. All right, Dan's going to get set up here. Dan leads our cloud operations engineering team on the PM side, so he's very well versed in what goes on there. Dan is from the Stackdriver team originally, so very well known, very well respected. So I'm going to hand over to Dan, who's going to talk some more about cloud monitoring and cloud logging.
All right, thank you very much, Adam. Well, I have the pleasure of being the one between you and the free beer. So if you're really nice, maybe we can go quickly. I did promise Adam, he's sort of talked about this talk as a very visual one, so let's start with a visual graph. Free candy in the back for anyone who can identify the bad day in this chart. All right. We spend a lot of time staring at graphs on the monitoring and logging team. Things get a little strange, like when I walk into the office and someone sees that a graph starts to look like a mountain range or a sunset, and it kind of means that we've been in this sort of space too long. What we'll talk about is getting visibility into your application with cloud monitoring and logging. I'm the product manager for the investments that we're making in Google Cloud to make ops easier. Monitoring and logging are two of those. We have a lot more work that we have underway. So far today, we talked about compute, we talked about networking, and we talked about data analytics. What this is all about is how you can gain the right visibility into those services. And we have a small technical difficulty. It's fine. When we think about ops, really, it's, so we have a survey that we did around, how are people making their cloud customers making their sort of investments from an IT perspective. And as you can see, there are two slices of the pie around maintaining infrastructure and applications that are way too big, right? And so, my goal in life, our goal, is to expand the small slices of the pie here, the pieces that are really being used for building, right? Making investments in new application capabilities, making sort of forward-looking investments in your architecture. Okay? Making operational data more useful is at the foundation of this. Given that it's late, I'll tell a quick story. So I was one of the founders of a company called Stackdriver. I'm really excited to be back in London because just about 2 years ago, we launched Stackdriver here. Not in this facility, just down the street. When we started Stackdriver, it was our friend Izzy Azari and I. We were, I think, at my house, and we made a survey for cloud users, mainly Amazon Web Services users at the time. And really, we were looking for pain points, right? So, is the pain right now in cost, or is it in sort of performance, or is it in uptime, right? And what we got back, hundreds and hundreds of responses, what we got back is visibility. So people who said, we're surprised, we're spending a lot more time than we expected, just trying to keep a handle on what's going on, with our application. And so we were really surprised by that because, when we sat down to talk to the customers, they'd say, actually, for our infrastructure sort of monitoring, CloudWatch does fine by us, right? And then we go to cloud meetups, and you'd have people presenting actually the architecture of their monitoring system, right? So you're a startup, and you have a team of people who are maintaining an application to monitor your application, right? So we thought that that was kind of broken, right? This isn't what the cloud was supposed to be about, making huge investments in infrastructure and tools as a company that's really about, a startup building a new application. And so, we dug in, and what we saw was, for example, with Amazon, people would use CloudWatch for their infrastructure monitoring, and then you'd say, well, that's great, and then they'd say, well, for system monitoring, we use Nagios. Nagios users in the house, right? Collect-D, Stats-D, Ganglia, right? And then you go above the system level stat, and maybe if you're using Cassandra or MongoDB, you have a dedicated monitoring service for those, right? Maybe one of each. And then as you get into the application, if you have some custom application metrics, you want to count how many images you're processing, well, for that, we have a separate graphite store, right? And we'll trend that over time. And perhaps if you want to measure uptime, you have another service that just sort of pings your customer-facing nodes and alerts you when those go down. And so, when we step back, we said, well, this is kind of strange because these are all just signals, and people are asking some pretty simple questions, right? Is my service running? Is it fast? What went wrong, right? And so, we started down this path, and now Stackdriver is part of Google, and we're continuing that path as a broader team of, making ops much easier, right? And so at a minimum, what we're here to do is provide customers with the choice of using an integrated suite to help get the information that they need out of their application from a performance and uptime perspective. Okay, and so we're thinking about it broadly in 3 areas. Visualization, so being able to visually see trends in the data, anomalies in the data. Analysis, so tools that are just part of the system that ask those same questions for you. And then finally, notifications. These are the things that wake you up at 3 o'clock in the morning. You're welcome. So monitoring and logging, cloud monitoring. So first, it's about full stack, right? So this is integrating at the application level, at sort of the open source software level, at the system level, and at the infrastructure level. Powerful alerting, so we'll go through this in the demo, but providing really, really flexible ways of sort of reducing false positives and alerts, right? So if we're going to wake you up at 3 in the morning, we hope that it's for a good reason. Native integration, so what this means is sort of fitting into the ops ecosystem that you already have, right? And so this meant for us, we're integrated with PagerDuty, HipChat, Campfire, Slack, Webhook. You can go down the list of services that we've integrated with. And then rich visualization we've already discussed. So the monitoring side of the service, so really easy to set up. In fact, if you're a Google Cloud user today, you go to the console, you click on monitoring, and then dashboards and alerts, and you're set up, right? You don't have to spin up a bunch of machines to serve the monitoring infrastructure. Integrated, so this means we've talked about the third-party tool integrations, but also bringing together uptime monitoring, system metrics, infrastructure metrics all into one place. Modern, so this set of technologies were invented in the cloud era, right? And so we care a lot about distributed systems, right? So if you have a load balancer in front of a cluster, and that cluster is passing data to another cluster using a messaging service, right? These are patterns that have evolved over the past couple of years if you're using auto-scaling. And so the service supports these types of patterns very natively. And then finally, scalable, like everything else we talked about today. The backend for the system is the same backend that monitors Google's global infrastructure. So you don't have to worry about how you scale the monitoring service. And so good news, it's in beta, and currently it's free in beta. So we have thousands and thousands of users for the service today. This is just a quote from HTC. What gets us really excited is that a company like HTC is relying on the service to tell them when something goes wrong, right? And then the second part of the quote here on the left is that they're saying that because they use the service, they can dedicate their engineers to their primary business. And so this sort of tells us that we're on the right track. Cloud logging, so if cloud monitoring is the thing that wakes you up at 3 o'clock in the morning and tells you when something's wrong, Cloud logging's the way for you to drill down and see exactly what that issue is. Okay? And that's, at times, we're also conducting analysis of logs automatically. So soon you'll have the ability to search in your log data and then define a metric that feeds into the monitoring system. So then we're constantly analyzing the logs data to look for that pattern, and you'll be able to do things like alert on it or show it on charts. Right? And then finally, integrated with value-added services. We mentioned earlier the integration with BigQuery, so we're really excited about that. I'll show you how that works. Yesterday, actually, we announced an integration with another third party, a logging service called Log Entries. Right? And so you can export the data to a logging tool of your choice. Logging, so the first thing we did, built a super solid API and logging pipeline so that you don't have to. Has anybody tried to scale up their own logging service? It's not easy, a lot of data, a lot of volume. Second thing is the power of the analytics tools. We'll show you those. Integrated, right? So this means that the logging service is also integrated with the monitoring service, right? So you can easily pass between the two to go from a metric to the relevant logs. And then finally, secured. Data is encrypted, in transit, at rest. You have control over who has access to the service. So that's monitoring and logging. What I'll do now is I'll dive into a demo of the two. We could bring up the demo. Cool. So this is Google Cloud Monitoring. Don't worry, I'll zoom in when we need to zoom in for those in the back. The first thing we'll do is, I call this late afternoon mode. We'll make it dark. Ooh, yeah. Monitoring. I'll give you a quick tour of the monitoring console. In the top left, we have uptime checks. So these are basically probes that evaluate whether your internet-facing resources, things like load balancers or websites or web servers, are available from 6 different regions. You can create your own. We'll do one here. Oh, I'm zoomed. So here I'll create, for example, a check to look over HTTPS, add a specific URL. We'll look for cloud.google.com. And I care only about the monitoring and logging links. So we'll look at monitoring. We'll check every 5 minutes. I want to make sure that, for example, alert is in the text. So you could create, for example, a health check page that we probe, and you can have that surface certain messages if there's something going wrong. Okay. So we can test that. Came back OK. And we can save that, and then you'll see that added as a new uptime check here in the top left. Next, actually, with uptime checks, this is a good example in terms of getting really easy to set up. The first time you use the service, you'll actually see suggested uptime checks. So we analyze which of your resources are internet-facing. Right? So for example, a front-end module on App Engine, and we'll suggest that you create one there, and you just have to accept it if you want it to be created. Okay? Next, you get an at-a-glance view into the health of your App Engine modules if you're using App Engine. If it's red, that means that there's an alert or issue detected with the module. And again, this is with no configuration, so we just discovered the resources and start monitoring them. Finally, groups. So this is a really powerful concept. Groups are dynamic filters. So basically what you can do is you can define, based on whatever criteria makes sense for your environment, what should be grouped together. Right? So for example, here, let's say I have a set of Redis nodes. If I save this, it's based on the filter name contains Redis. If I save this, any new nodes that have Redis in the name will be added to that group. Right? And what that does is when the status of the group is rolled up. So you'll see, again, if everything's healthy, here I have one for Asia, Europe, US, and so forth. If everything's healthy in the group, if there are no alerts, I see green. If there's an alert, I see red. I can also drill down and have groups within groups. So I can have, for example, within Asia, perhaps I have a production environment and a dev environment, and I can break those out. Moving on to the bottom right here, event log. So the event log is really a record of everything that's changed recently in your environment, right? So this could be, for example, let me zoom in. For example, this could be, let's look at all the events lately in terms of instances changing status. So someone retired a node, right? Or somebody added a new node. We can also look at certain API calls. We can look at alerting policy changes. We can add our own events. So I can say, Dan's doing a demo. Please do not deploy. Okay, so that's the event log. Above the event log here in the middle, I have sort of KPIs for my environment. And this is configurable. So in the main console, you can show whatever metrics make most sense for your team. Okay? And then finally, above, I have incidents. So these are active alerts, things that I need to take action on. Okay? And as I mentioned, the alerting system is extremely powerful. If I can get back to it. Actually, I'll go into an environment that has more systems in it here. So here, from an alerting perspective, I'm going to focus on Cassandra. And I can define alerts. I can define simple alerts like, why don't you wake me up in the morning if for my Cassandra 1 node, if the metric, let's see, load average over the past 15 minutes is above 1. There you go. Well, we'll say above 2. So I can save that as a condition, and so now that will fire if CPU load average is above 2 for that time frame. Right, but actually, I have many Cassandra nodes. So what I probably want to do is, and this is where the group concept comes into play, is across my entire Cassandra cluster, I think I'm running a 42-node Cassandra cluster here. What I might want to say is across that entire Cassandra cluster, instead of, I could say if any member, right, if any of my Cassandra nodes CPU load goes above 2, then generate the alert. Or I can be more sophisticated. So for example, what I really care about is don't wake me up if it's just one of them. So why don't you tell me if more than 20% of the cluster is unhealthy? Okay, so I can save that. 20%, what would we say, CPU load is above 2. Oh, this is above it for 5 minutes, so we'll use 3. Or I can look at aggregates. So I can say, well, what I'm really concerned about is across that cluster, I want you to notify me if the, for CPU load, let's say load average 15 minutes, if the maximum is above some value, or the minimum, or the 95th percentile, right? And so the alerting system is really expressive in terms of the ways that you can describe, or the conditions under which you want to say, wake me up, right? And so what this does for you is it makes it so that ultimately you get fewer false positives and less alert fatigue, right? And so the other thing, actually, that we'll point out is, let me just save this here, is in this process, I haven't been creating different alerts. What I created actually is a single alerting policy, and I can say, well, look, don't wake me up unless all of these things happen at the same time. Okay? So that's the sort of tools for analyzing the data and creating alerts. You can also use different ways of notifying you when there are alerts. So as I mentioned, I can have a simple email and say, email Dan, please don't do that. I can also say, let's say I use PagerDuty. Right? A lot of our customers use PagerDuty, which basically handles on-call rotations and escalations. So I can say, well, send the notification directly to PagerDuty, and all that you have to do is configure the PagerDuty API keys. You don't have to actually build any integration. We've done that for you. Or if you use Slack, we can notify a Slack channel. And again, you can do all of these things at the same time. So you can have, for example, you can have some alerts that are really just a heads up, and so you might want those to be triggered into the chat room, and then you might want others that actually send SMS messages to your ops team. Okay? And then finally, please do this. If you start using the service heavily, there is a rich documentation field. So this supports Markdown. You can provide really rich information on what someone should do if they get that alert, right? And we don't actually see enough use of this. We want to try to increase that. Okay, so that's alerting. Final piece of the monitoring system that I want to show you is dashboards. So dashboards are very flexible. They're a way for you to say what you want to stare at, right? So this gives you a sense of the dashboard that we have up on the wall in my little space of the office here. So what we're looking at here is processing of metrics, right? So we have billions and billions of metrics that we're processing every day. This is our way of just having a visual cue into whether the pipeline is performing as expected. Okay? And so you can configure custom dashboards to show any amount of data. So for example, these are custom metrics that we've configured our application to send to our API. I can choose to aggregate these metrics. So here I have dozens of lines on a chart. Sometimes we have customers that have hundreds or thousands of lines on a chart. In that case, often the chart becomes very noisy with thousands of lines on it. So what you do is choose an aggregation. So you might say, show me the 95th percentile across all this data, or the mean, right? You can also, let me jump back to the other interface here. We'll look at, you can also decide that you want to show a threshold on the chart. So you can say, well, visually, I just want to have a cue on that big dashboard that shows basically for, just by the eye, that it's above the level that is acceptable by definition of our team. Okay? And then finally, I'm going to jump one more time between views. You can look at this as a full screen view, again, for that big screen TV in the office. And you can, we have this mode called X-ray mode, right? So again, if you have thousands and thousands of nodes, a lot of time color isn't a good way to differentiate between the different lines. And so what we've done is created basically a visual heat map over time. So you can't really see it as well on the screen, but we use translucency to basically, transparency so that when you're looking at a big set of lines, the areas where they overlap get made more opaque. And so in a big data set, say you have half of a chart filled up with lines, the X-ray effect shows you where the central bands are in that data set. Okay? And so that is cloud monitoring. Now we'll jump over actually to cloud logging. One thing I'll show you how we can get to cloud logging. So one is you could go into the console and access cloud logging directly via the left-hand nav under monitoring. The other way that you can do it actually, because they're integrated, is if you're looking, for example, at, let's say, an App Engine module, when it comes up, you can access the logs directly from there. So for example, you got an alert at 3 o'clock in the morning, you find out that it's from your, we'll say our comments module. From our comments module, we can go directly to view the logs for that module, and the filter will carry directly through. And this is an area where we're making a lot of investment to kind of bring the monitoring and logging systems closer together. So here, you see the logging interface. Unfortunately, for the fans of the dark themes, we don't have that yet for logging, but I hope we'll work on it soon. So here, I'm looking at the logs from my App Engine module. We're filtered to App Engine. I can also send data from Compute Engine. We use FluentD as our plugin. Just like the monitoring side of the service, it's integrated. So if you send your data through FluentD, you can also send, for example, your Apache logs, your system logs. From a logging perspective, so here I'm looking at my App Engine logs for a particular module in a particular version. Here I'm just looking at my request logs. I could choose only to look at critical and error logs. So here I can only see those. I can also search. So for example, let's see, Molly as a user, and I want to see what are the the most recent logs relate error logs in this module where the text Molly is present. You can also stream the logs. So if I get rid of Molly here, I'll be able to basically see, actually, well, the Molly filter still applied. I'll be able to see when new logs come into play that contain that text and that match this filter. Okay. And then, as we talked about before, we can export the log data to BigQuery, right? So the logging interface is very flexible, but there are certain types of queries that we can't anticipate that you'll want. So you can export that data to BigQuery. You can export it to GCS, cloud storage for long-term archiving. And you can also publish it to a pub subtopic. And when I mentioned that we're integrated with log entries as a third-party logging service, that's the way that you integrate with a third-party logging service. You publish the data via pub sub, and then they subscribe to the other side of that. Okay. And so we'll just jump into BigQuery and show a little bit more advanced data. So here I can see my App Engine logs that are streaming into BigQuery, right? And what I'm going to do here is I won't write the query, but you can see, let's see here. So I have a query basically that looks for the 95th percentile latency across my paths within App Engine, right? And so I'll run that query. I have 11.5 gigabytes of data. And in 6 seconds, it came back with the 95th percentile latency ranked by latency across my App Engine paths, right? And so by streaming the data into BigQuery, you have a very interactive way of asking new questions of your log data. So can we go back to the slide deck? That's it for the demo of cloud monitoring and logging. As I mentioned, this is an area that we're really excited about because we think there's a lot of opportunity to do the googly thing, right? So to look at all this data that is out there and make it more useful to you. So you can learn more about our investments in this log space at cloud.google.com/monitoring and cloud.google.com/logging. And that's it. Thank you very much.
All right, so that brings the afternoon sessions to a close. We are all going to be here drinking beer and wine with you for the next hour or so, so please join us. All of the speakers are going to be there. I will be there. Please come ask us your questions. We want to make sure you get everything you can. Please join me in thanking all of the speakers one last time, and please, I hope you enjoy the day, and look forward to talking to you shortly. Thank you.